Okay, so now we're going to actually use percent abundance to figure out the average mass of something. So one way that we talked about in class was on this slide right here that I put in. This is going to tell us our relative atomic mass. I'm going to delete this just so we can do some math on this page, but I wanted you to see it and recognize it so you can go back to your chapter 4 slides and look at those there. But he gives us an equation down here at the bottom before I delete this, right here. This is the equation that we want to use to figure out what the relative atomic mass is for that element. So let's delete this to give us some more room. Okay, so remember that an element that we see on the periodic table, its mass is a is an average of all of the different isotopes that exist for that element. So for example, we talked about carbon in class, and we know that carbon has 6 protons and it has a mass of 12. So let's go back down here and talk about this for a minute. So carbon has a mass of 12 and it has 6, let me write mass, it has 6 protons, 6 neutrons, and 6 electrons. But there are other isotopes of carbon that exist. So some carbons will have 6 protons and 6 neutrons, right? This. And then some other ones are going to have 6 protons because that never changes, but they'll have 7 neutrons. And that changes the mass to 13, right? That's our mass now for that isotope. So these are different isotopes. And in nature, all of the elements exist in different isotopes. So we are going to use the percent abundance in this chart that we have here for lead, and we are going to figure out what the average for that is going to be. So the average weight for lead. Okay, so all that we have to know from this is that our relative atomic mass, or RAM, is going to equal the percent abundance which we see right here, divided by 100, and that's going to be times the mass of that average, or of that percentage. And then you do this for each one, you add them together, and that's going to give you, let me erase that and put mass, sorry, your relative average mass of all the isotopes of that element. So let's do this for lead. All right, so we have, do our relative average mass for lead. And one way I can remember lead as being PB is I don't want lead in my PB&J sandwich. That's how I memorize lead, just so you know. So I'm going to put, we have a 1.4% abundance divided by 100. And we're going to multiply that by that mass, which is 204. Okay. We're going to add this to the next one, which is 24.10% abundance divided by 206. That's our mass. Oops, I'm sorry, not divided by 206. Divided by 100. And that's going to be times our mass, which is 206. Okay, and I'm running out of room, so I'm going to go to the next line, but we're still continuing on with this chain. We're just going to the next line here. And now we have a 22.10% abundance of 207. And we're going to add that to the last one, which is 52.40% of 208 mass. Okay, so I didn't pull up my calculator to do this on my iPad. So if you want, you can just fast forward the next like 30 seconds of quiet while I do this on my calculator. So we want to do 1.4 divided by 100 times 204. And remember to use your parentheses for all of this. In fact, let's just go ahead and pull up a TI calculator. So we want to do TI calculator. Let's just go ahead and do it on our together. All right, so we're going to have to pop back and forth. So we have 1.4 divided by 100. Actually, let me just pull up that question. I can look at the chart. Okay, so remember to do your parentheses. Very, very important. So we have an abundance of 1.4 divided by 100, because we don't want it in percentage. And we are going to multiply that by the mass, which was 204. Okay, and I'm going to do this for each one, and then I'll add them all together. So then we do a parentheses, and we do 24.10% divided by 100. And we're going to multiply that by the mass, which was 206. Okay, and then we're going to do 22.10 divided by 100. Oops, look what I forgot to do, my parentheses. 22.10 divided by 100 times our mass, which was 207.0. And then the last one was 52.40% divided by 100 times our mass, which was 208. And now I'm going to add these all up. So I have 108.992 plus 2.856 plus 49.646 plus 0.747. And we get 207. Make sure I did that right. Okay, I think I used all the right numbers. Oops, I forgot the number we said. 207.241. 207.241 is our average, our relative average mass for all of those different isotopes for lead. So that is how, I do think there might be a question like this on the test, so recognize that this is how you find the relative average mass of all of the different isotopes that exist. You just take the percent, divide it by 100, and multiply it by the mass, and you add those all up together.